Okay, good morning to all of you. Today I am going to discuss the monostable multivibrator, right? Mono means single, stable means stable state. It has one stable state and one quasi-stable state. Stable state means the device will stay permanently on that state, right? If you want to change the state, if you want to change the device on that state, we have to give the external input signal, then only it will be changed. Otherwise it is in that state, right? So monostable means mono means one, it is having one stable state and one quasi stable state. So if you want to understand the operation of monostable multivibrator, you have to know about the transistor operation. When we are giving positive signal to the transistor, that is a common emitter configuration. So the transistor starts to conducting, so it is entered into the saturation, right? When the transistor is in saturation, the current flowing through the transistor is maximum, and voltage between the collector to emitter, that is output voltage across the collector to emitter, is 0.7 volts, which is also called BCE SAT. So it is approximately zero. So when the input is positive, current is maximum and voltage is minimum, that is zero. So it acts as short circuit, right? So for the positive cycle of the input signal, the transistor acts as short circuit, so it acts as on switch, right? For the positive half cycle, current is maximum and voltage is minimum, that is approximately zero. Similarly, for the negative half cycle of the input signal, the transistor enter into the cutoff state, right? Because base to emitter junction reverse bias, collector to emitter reverse bias, right? So due to the cutoff state, the current flowing through the collector to emitter terminals is zero, and voltage, output voltage in between collector to emitter is whatever we are giving the collector, that is VCC voltage, it will be appeared in between collector to emitter. So VCE is equal to VCC. In cutoff state, output voltage is maximum and current is zero. So it acts as open circuit because voltage is maximum and current is zero. So in open circuit, transistor acts as off switch, right? So for the positive input signal, current maximum and voltage zero. For the negative input signal, current is zero and voltage is maximum, that is VCC. This is the circuit diagram of monostable multivibrator. It is designed by the two transistors. Transistor is also called inverter, right? Two inverter transistor it is designed. So see here, both the transistors are connected in cross coupling manner. So first the capacitor C1, first forgot about this capacitor, right? After I will explain what is the use of this capacitor, right? So Q1 output is given to the Q2 input through a capacitor, right? So by the capacitor, through the capacitor, we are giving Q1 output signal to the input of Q2 transistor. Similarly, Q2 output, that is second transistor output signal, is given to the input of first transistor through resistor R1, right? So one coupling element is capacitor, which is called AC coupling, right? So other coupling element is called resistor, which is called DC coupling, right? So in monostable multivibrator, one coupling is AC coupling and other coupling is DC coupling, right? So here we are giving negative voltage minus VBB to the transistor Q1, right? So this is the supply voltage, and RC1, RC2 both are collector resistors, right? So this is the components and this is the circuit diagram. So see here, when we are giving a negative voltage to the transistor Q1, so supply is switched on. So both the transistor try to the conducting state. So but here for the transistor Q1, we are giving negative voltage to the base terminal. So by giving negative voltage, transistor entered into the cutoff state, right? So when the transistor is in cutoff state, output voltage of transistor Q1 is transistor cutoff output voltage VC1 is equal to VCC, right? So the transistor Q1 acts as open circuit, right? Off switch. For the transistor Q1, we are giving negative voltage. By the negative voltage, transistor Q1 is in cutoff state. The current flowing through the cutoff state, the transistor Q1 is 0. So the output voltage VC1 is equal to VCC, right? So see here, so transistor Q1 acts as open circuit, right? So here the supply voltage VCC is given to the resistor or and collector resistor. So the supply voltage is applied in between the resistor to the ground terminal of transistor Q2, right? So supply voltage is applied between the resistor and ground terminal of transistor Q2. Due to the supply voltage, the transistor Q2 entered into the conducting state. That is the transistor entered into the saturation region, right? So the voltage across the collector to emitter of transistor Q2 is VCE sat, that is approximately 0 volts, right? So when we are giving negative voltage to the base terminal of Q1, Q1 is in cutoff state, it acts as open switch, and VC1 is equal to VCC. So supply voltage is given to the RC1 and similarly resistor R2. So supply voltage is in between R to the emitter terminal of Q2 transistor. Here Q1 is open circuit, right? So due to this voltage, the transistor Q2 entered into the conducting state. So the output voltage in between collector to emitter of Q2 transistor is VCE sat, that is approximately 0 volts. So this is the stable state of monostable multivibrator, right? So VC2, this is 0 volts. So 0 volts is given to the Q1. Q1 already off condition, right? So VCC is applied in between resistor to the emitter terminal of transistor Q2. Due to this voltage, transistor Q2 always is in conducting, that is saturation mode. So output of Q1 is VCC, output of Q2 is VCE is at 0. Output of Q1 is VCC, maximum voltage. Output of Q2 is 0.7 or 0 volts. This is the stable state of monostable multivibrator. Okay, now so see here, Q1 off condition, Q2 on condition. By the negative voltage, Q1 open circuit. So output voltage VCC. By the supply voltage to the R2 resistor and base of transistor Q2, the transistor Q1 is in on condition, output voltage is 0.7, approximately 0 volts. This is the stable state, right? So see here, there is a capacitor in between Q1 to the Q2 base. Due to this capacitor starts to charging from the VCC to the RC1, right? So capacitor positive terminal is RC1 and negative terminal is base of transistor Q2, right? Capacitor starts to charging, and if it is charging, when the capacitor is charging, the voltage across the capacitor is not applied to the Q1 transistor because transistor Q1 is in open circuit, right? So due to the open circuit, voltage across the capacitor will not appear across the base to emitter of Q2 transistor, right? So now, if you want to change the state of the monostable multivibrator, that is stable state, we have to apply the external triggering pulse, right? So here we are giving positive trigger pulse, input trigger pulse through capacitor we are giving to the transistor Q1. By this signal, we can change the state of Q1 and Q2, right? We are giving positive trigger signal to the Q1 transistor. By giving positive trigger signal means positive voltage. By giving positive voltage, Q1 entered into the conducting state. That is, Q1 is in saturation state, right? So So current flowing from VCC to through RC and C, voltage across the capacitor increases, but Q1 is in open circuit where the voltage across the capacitor will not be appeared in between base to emitter of Q2. Now you are giving positive trigger pulse to the base of Q1 transistor. By giving positive trigger pulse, transistor Q1 entered into the conducting state, that is Q1 is in saturation mode, right? So when the transistor is saturation mode, output voltage is VCE sat, right? In previous condition, in stable state, output voltage of Q1 is VCC. By giving positive trigger pulse to the Q1, the state will change from VCC to the 0.7 volts, that is VCC to 0 volts, right? So in previous condition, the capacitor charged to VCC, right? So by applying external trigger signal to the Q1 transistor, Q1 acts as short circuit, right? So there is loop here. So voltage across the capacitor and transistor base to emitter voltage is given to the Q2 transistor, right? Already capacitor is charged, right, to the VCC value. Here capacitor negative terminal connected to the base of Q2, right? So by giving negative terminal to the base of Q2, so minus voltage, that is negative voltage, is given to the Q2 transistor. So by negative voltage, transistor Q2 entered into the cutoff state, right? It acts as open circuit. In previous condition, in stable state, transistor Q2 is in on condition. So output voltage is 0 or VCE sat. By the charging capacitor, by acting short circuit of Q1 transistor, there is a loop here. Due to this loop, the voltage across the capacitor and voltage in between collector to emitter of transistor Q1, this total voltage is given to the base of Q2, right? So negative terminal connected to the Q2. So by the negative voltage, Q2 entered into the cutoff state. So output voltage is changed from stable state to the some other state, right? In previous condition, output voltage is 0. Now, output voltage is 0. Now the output voltage is VCC because the Q2 transistor is in open circuit, right? So Q1 is short circuit. So the capacitor is charging in reverse direction. So from VCC to the R2, the current flowing from VCC through R2 through capacitor and transistor Q1. So the capacitor charging from minus VCC to the maximum value of VCC. When the capacitor starts to charging, the voltage across the capacitor increases, right? When the capacitor voltage increases, when it reaches to the 0.7 volts, this voltage is given to the base of Q2. Right? So when voltage across the capacitor is 0.7, which is given to the Q2 transistor, then transistor Q2 entered into the conducting state, right? Q2 transistor entered into the saturation region. So it acts as short circuit. So it acts as short circuit. In short circuit, output voltage is 0 volts, right? So here we are not giving any external triggering pulse. Due to the short circuit of Q1, capacitor will be charged in reverse direction, positive to negative, positive terminal connected to the Q2. So the transistor Q2 entered into the saturation mode. So in saturation, output voltage is 0. So it is automatically shifted from minus VCC to the 0 value, right? So voltage in between collector to emitter is 0. This voltage is given to the base of Q1 transistor through resistor R1. So 0 voltage is given to the base of Q1. So Q1 acts as open circuit because 0 voltage is given. So transistor Q1 is in cutoff state. It acts as open circuit. In open circuit, output voltage of Q1 is VCC. So it is shifted from 0 volts to the VCC. Okay. So again, it is come back to the stable state, right? So in first condition, output Q1 is in off condition. Output voltage of Q1 VCC. Output of Q2 is 0. Right? This is the stable state. Now we are giving external triggering signal. So by this Q1 short circuit, Q2 open, right? So capacitor will be charged. Due to this capacitor charging, Q2 becomes saturation and it is on. So output changes from minus VCC to 0. So this 0 voltage is given to the Q1. Q1 becomes short circuit, right? So again it come back to the stable state, right? If you want to change this stable state, again we have to give the external positive trigger pulse. Then we can change the state of the signal, right? So these are the output waveforms of monostable multivibrator. In first condition, see here, Q1 off, Q2 on. This is the output, VB2 output voltage. VB2 means second transistor base voltage. Okay, na? So second transistor base voltage, base terminal, we are connecting capacitor. So capacitor will be charged to minus VCC, and again it is charging from minus VCC to the 0.7 volts. Okay, from the minus VCC to the charging, and it maintains constant VBE sat, and again it decreases, that is charging to VCC, but negative terminal connected to the base of Q1. So here we are indicating minus VCC, right? Next, this is the output voltage of VC2. So this is the stable state. By giving external triggering pulse, so here we are giving external triggering pulse. By giving this triggering pulse, transistor Q1 entered into the saturation and Q2 entered into the off state, right? So when transistor Q2 is in off state, output voltage is equal to VCC. So output voltage of transistor Q2, which is VC2, is equal to VCC, right? So when the capacitor charges to positive voltage 0.7 volts, then transistor Q2 entered into the on state by without giving any external triggering pulse. This is the stable state and this is the quasi stable state. Automatically it is shifted from the VCC to 0 volts by the charging of capacitor, right? See here, the time width of output voltage of VC2, this is the time period of positive cycle. So this is stable and this is quasi stable, and again this is stable. By the monostable multivibrator, we can generate a gate pulse. This is the gate pulse. Okay, na? So this is also called delay circuit. If you want to calculate the oscillations, we have to calculate the time period for this positive half cycle, right? So if you want to calculate time period, the time required for this cycle is charging voltage, the charging capacitor. So in between this time period, the capacitor will be charged from minus VCC to the maximum value. Okay, so if you want to calculate frequency, we have to calculate the time period. So by calculating time period, we are calculating the voltage across the capacitor, right? So let's see the expression for frequency. So voltage across the capacitor VC is equal to V final value plus V initial value minus V final value into e power minus t by RC, where RC is the time constant, right? T is equal to T, capital T. End of time period, voltage across the capacitor is equal to 0. So initial value is minus VCC. Final value of voltage to be charged is plus VCC, right? So initial value is minus VCC. Final value of capacitor is plus VCC. Voltage across the capacitor at T is equal to T is equal to 0. So VC is equal to 0 is equal to V final value plus VCC plus initial value minus VCC minus of V final VCC into e power minus at T is equal to T. We are calculating at T is equal to T. So by substituting T is equal to T, e power minus T by RC. Right? So when VCC it is entered into the right hand side, it will become negative. So negative cancel. VCC is equal to 2 VCC e power minus t by RC. So VCC cancel. VCC cancel. E power minus t by RC is equal to 1 by 2. E power t by RC is equal to 2 by taking log on both sides. So ln of e base e power t by rc, right? Power will come at base, so e power t by rc into log e base e is equal to ln of 2. So ln of e base e is equal to 1, so t by rc is equal to ln of 2. Ln of 2 value 0.69, t is equal to 0.69 rc, right? This is the time period, the for the gate pulse of monostable multivibrator, right? So if you want to calculate frequency, frequency is the inverse of time period. F is equal to 1 by t is equal to 0.1 by 0.69 rc, right? So this is also called single step. So by the monostable multivibrator we can generate single step. This is the output waveform, right? In stable state 0. So right, again by giving positive trigger pulse, we are changing the stable state 0 to the VCC. Again automatically it is shifted from minus VCC to the 0. So it is by seeing this waveform, it is similar to the pulse waveform. Okay, so it is the another name of monostable multivibrator is single step or univibrator, right? So by the monostable multivibrator we can generate a rectangular waveform or gate waveform, right? So this is about monostable multivibrator.